The timer on delay, or TON instruction, for the Allen Bradley SLC 500 uses data file 4. The file type is T. The address of timers will start with T4:, followed by a unique integer for each timer. Each timer requires 3 16-bit words. Word 0 contains the status bits. The EN, or enable bit, is true whenever the timer instruction is true. The timer timing bit, or TT, is true whenever the timer is timing. The DN, or done bit, changes state when the accumulated value equals the preset value. For the on-delay timer, the DN bit changes from 0 to 1. The accumulated value, the third word of the timer instruction, is reset to 0 when the instruction is false, and when the instruction is true, increments until it equals the preset value. The preset value, the second word of the timer instruction, along with the time base, determines the length of the time delay. In this example, the preset is 50 and the time base is 1/10. Therefore, the time delay will be 5 seconds. With a timer on delay, when the rung before the instruction is false, the accumulated value is reset to 0 and the DN, EN, and TT bits are 0. When the rung becomes true by closing switch I:3/0, the EN and TT bit are set to a 1 and the accumulated value increments by 1 for each time base increment. The time period is the preset value multiplied by the time base. In this case, it would be 100 times 0.1 or 10 seconds. When the accumulated value reaches the preset value, the TT is set to 0 and the DN bit is set to a 1 and the accumulated value no longer increments. The top ladder diagram shows a hardwired electromechanical timer that will start a motor 5 seconds after the start push button is pushed. The bottom ladder diagram is for a generic PLC. When the start button is pushed, the internal relay will latch around the start contact and the timer will start timing. The output of the timer functions like the normally open time-close contact in the hardwired circuit. In this simulated SLC 500 program, pushing the start button latches in the internal relay, which starts the timer on delay instruction. After 50/10ths of a second increments, the accumulated value equals the preset and the DN bit is set to a 1. The examine if closed instruction on rung 2 is addressed to the done bit T4:0/DN, which starts the motor. Another application of a timer on delay is to sound a horn for 10 seconds after the startup push button has been pushed. In the ladder logic program, the enable bit of the timer, T4:0/EN, is used to latch in the startup push button, PB1. The AND combination of the examine if open addressed to the done bit and the examine if closed addressed to the enable bit replaces the normally closed timed open contact from the hardwired relay circuit. Also notice in this simulation that the first two instructions on rung 1, could have been replaced by an examine if closed instruction addressed to the timer timing bit of the timer on delay. This application of a timer on delay forces 3 motors to start in a defined sequence. Motor 1, the lube oil pump motor, starts after the start push button is pushed. The main motor drive, M2, only starts when the pressure switch on the lubrication oil reaches a preset value. The feed motor will not start until 15 seconds after M2 has started. This is the ladder logic implementation of the previous hardwired relay circuit. This is the simulation of the sequential motor control. The action of PS1 pressure switch is also simulated by manually closing I:3/2 about 6 seconds after M1 has been turned on.